There you are again.
What do you know?
I know, it's incredible. What are you doing for spring break, Jasper?
I'm actually here for spring break. I'm not really
Me
doing
too.
anything.
I know. That sounds good to me, though. I'm excited. This is the first time I haven't done anything for spring break in a long time.
Really?
Yeah.
I mean, it's nice, like a little staycation, you know?
I know. I used to go every year to the Mediterranean because that's just the way I roll. But it was just not happening this year. So. Max Allen.
Where is everybody?
You know, that is a great question, but you're here.
I know, that's all that
Like, your favorite
matters.
students are
Right,
here.
Jasper?
So
That
who
is
cares
all that
about
matters.
everybody else?
No one cares.
I mean, seriously, SRSLY. That's what I have to say. What are you doing for spring break, my friend?
Nothing fun.
Me either. Except I'm sleeping late every day for 10 days.
Okay.
That's fun.
The change of pace.
I'm going to have study hall every day,
Oh, yeah?
which is actually, I like study hall. You know, when can you read when there's like noise around? Can you, Jasper?
No.
Not really.
Like, I can't concentrate.
No.
It has to
hard.
be like silence. Silence. This is how terrible the world is outside of independent schools, Charles.
Okay, I was worried for a
No,
second.
no. But isn't it sad? Common Core, which is like the big, what's happening in public schools, they're making them do math over spring break. Now, I think that's delightful, of course, but
I mean, who's not going to be doing math?
I know, duh. Charles, what are you doing over spring break?
I'm going up Idaho. Skiing.
You're going to Idaho?
Yeah.
Fun. Jack, how about you? What are you doing for spring break?
Winter?
Puerto Rico.
Puerto Rico. Huh? That's America.
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 So is Idaho.
No, it's not. Idaho is not part of America. Just FYI.
Your passport
Duh.
gate there.
You're silly.
I guess you failed geography. I've actually been in Idaho for literally 20 minutes.
They were a great 20 minutes.
It was a really moving 20 minutes. Yes. Because I went to Idaho, I stepped inside the border.
then you
I think
stepped
I may have used the bathroom in Idaho, and then I drove back to Montana. I didn't know that there were. I didn't know there were mountains high enough to ski in Idaho.
Well, they're high parts of the state where they have mountains going up from there.
Idaho. Where does the word Idaho come from?
I do not know.
It's sure it's some Indian thing. So I was asking people, when you read like a book for either pleasure or for, do you have music playing or do you need quiet?
How do you have music playing?
I have music playing if it's like a history textbook.
Really?
See, that's
No,
I
I'm the
can never-
opposite. I have
can
music
never
playing
do
if
that.
it's like an online article or something.
Yeah. I just cannot. If there's noise, forget it. Hello, Isabel.
We're having a Chinese fire drill.
Are you?
This class.
Why?
We're rearranging.
We have rearranged.
Yeah, you're all the
You
way
can sit over
there.
here if you want.
No, I mean in the classrooms.
What? What's a Chinese fire
Because it's
drill?
then when
That's in the
everybody
car.
gets out of the car, like the cars that are late, everyone gets out, rearranges where they're sitting.
Uh-huh.
'Cause it's
Oh,
the,
I love
end,
that.
the end of the second semester.
It happens all the time.
So on the count of 3, everybody has to get up, run around, and get in a different seat.
No, that's too much work.
Can we go to the other room?
Yeah.
Okay,
Okay, so you
Go.
we reject your idea. That's all I can say.
But we gotta switch up the room.
Wow.
Well, but you're sitting in a different place.
Yeah, we should go over there and get some natural light.
So, Isabel, we were talking about what we're doing for spring break. What are you
Do
doing?
they know who did it?
No, they don't.
I'm climbing Machu Picchu.
Crazy.
Yeah.
Make sure. Make
The world's
sure
about to
it's a
end.
guinea pig.
Yeah.
Make sure to not get altitude sickness.
I know.
No,
It is
it gets us-
rough.
Oh, I thought it was lit.
It's rough. It really is rough.
Convert that into meters, Charles.
Eric, what are you doing for spring break?
So you're down to about 1
Me?
month.
Yeah.
Oh, wow.
I'm going to Patagonia with my family.
Oh my goodness! Everyone is going all
Eric,
over.
let's meet up
Where's
in
Eric
South
going?
America.
Wait, Izzy, where are you
I have
going?
to see-
Peru.
Oh, hey.
That's like thousands and thousands of miles away from Patagonia, but that's okay.
That's okay. Road trip.
Isn't Patagonia like
Right,
the
exactly.
desert?
Hello, Trinity
Like, doesn't it
Prep.
have a
The
desert?
Andes Mountains.
What's up? No idea.
Isn't there? There's like somewhere where it hasn't rained in.
Is your spring break starts this Friday?
Oh, it's the Atacama.
This is sick.
Samia, your spring
Six
break starts on
happens.
Friday?
It does.
I mean it's the Atacama.
When is your spring break?
Well, today's our last day.
Yay! Spring break
That
is the
was
best.
good school though.
What's wrong with this charger?
I don't know, and
It's working for me, so don't
I
touch it.
hardly even recognize half of the people in Trinity Prep.
No, you don't know where everyone is. Oh wait, I think Akshay's in tennis game and Sam has like. Sam has like.
Sam's still in English. He'll be here soon.
Okay, you're creepy, Isabel. Let's get that under. Hi, Alex.
Charger to work.
Hello.
When does your spring break start?
What was that?
When does your spring break start?
Oh my god, it was glued
I
back
have
together.
one more. I have next week. Next week I have school, and then I have 2 weeks off.
Yeah. So we're off. Not they have exams next week, which is
Should I
delightful.
just go first name? Seems like everyone just does first name these days. Yeah.
Okay. Okay. So welcome. This is our last class for a long time. We're actually going to have class. Our next class will be in 3 weeks. Believe it or not. So I'll talk about that in a second. I think it's 3 weeks from today we'll next meet. But anyway, so here we go. Here's the first thing I want to talk about is I want someone to explain
thing's
this
broken
picture to
again.
me.
Where
I
is
think-
everyone?
Oh no! Why is our network connectivity lost?
My thing's not. Yeah.
What is happening?
Autocorrect.
The last class can't happen.
It's
No
going to-
class. Oh no.
Wait, there's a math practice packet?
Not for you. It was for some elementary school. Okay, so anyway, I'm waiting for someone to
boom.
volunteer.
Once in England, our teachers gave us what they called ho ho homework.
Oh.
It was really not fun.
Oh, no one?
But was it funny?
No, it was like
Thank you,
30
Max.
pages to do it for Christmas break.
Max is volunteering. I love that. Max, okay, go for it.
Okay, so I guess what we're looking at here is kind of it's a representation of an infinitesimal amount of volume in cylindrical coordinates.
Yes, it is.
And so I guess what this made me think of is one of the videos that you had us watch, one of the Massey videos, where he explained when we were doing area using double
Yep.
integrals in cylindrical coordinates, we had RD theta because is it R times D?
So why is this thing here RD theta?
Yeah, so RD theta, it's because that the radius times the change in theta,
Uh-huh.
I guess, geometrically gives you the arc length.
Yeah, S equals R theta, right? Arc length is R theta. So R times the change in theta will give you this distance.
Yeah,
So then the volume of this box is what? So it's this thing is RD theta
RD theta and
times
times dr
times.
times dz.
Okay, so that's where the R dz dr d theta comes from. Okay, so it's from this, just the fact that this is R d theta. Now this is much more complicated. Much more complicated.
Ooh.
This is in spherical coordinates. I know. Who feels like they can explain some part of this at least?
I like this one. I feel like I can explain it.
Okay, Samia?
Okay,
I thought I heard you say, I feel like I can
That was
explain.
me.
Oh, I'm sorry.
that was Isabel, but I mean,
That's
I
okay. Can you tell part of it
Where's
to
the
me?
other two?
Yeah. So for the just us. So for the rho d phi, I think
Yeah.
that's like basically the same reason that that r d theta is that length because just like that's kind of like a formula because
Okay.
it tells you like that sector, I guess you could say.
Excellent. Great. Okay, and so that's definitely true, and I understand where the d rho comes from. This is the hard one. Isabel, do you want to explain this?
That it's rho sine phi
Yeah.
theta. Well, I mean, if you, I mean, it's about. I think it's just about like right triangles and then, or triangles themselves, and then just like calculating side lengths. To be honest, but.
Well, okay, so yeah, it's just using trigonometric stuff, okay, and rho sine phi. It's like when you do vector vector components in physics. It has to do with, rho sine phi will give you this length. So again, you're going to multiply rho sine phi d theta times rho d phi, and then times d rho, and that will give you this crazy expression.
Can I go get tissues, please?
Yeah, there's some in my office. Okay, let's try this. Sketch the volume. Oh my gosh, a sketch a volume. So, yay. Raheem, I've never seen you without glasses.
Yeah.
Did you have LASIK surgery between Monday and Thursday?
No, I have contacts.
Why would you ever wear contacts? It's like you're putting your finger in your eye.
I mean, you just drop it in.
Are they hard or soft?
They're soft.
Yeah, see, it scares me.
Why would they be hard?
Well, hard ones feel like you have like sand in your eye.
Well, I wear hard ones at night, and then I take them out in the morning.
See, there you go. And do you wear soft ones during the day?
No, I just
You don't wear any?
they shape my eyeball during the night so that
How bizarre is that?
during the
That
day.
is
They reshape your eyeball as we go.
Put your glasses.
Contact lenses.
Wait, so Charles, if you stay up late, does your eyesight get really bad?
No, I can probably go like about like a day and a half before it starts getting bad.
Oh, okay. That's cool.
How did I reshape?
Because it's just like they're a mold.
Oh, they're a
in your eye.
mold.
They're just like hard contact lenses.
Yeah, hard contact
That
lenses
I wear.
actually mold.
I wear them at
your eyeball.
night, and then they like shape my eyes. into
When you
lenses.
sleep?
Yeah, and then I take them out in the morning, and I just see normal.
Okay. I think I can draw this.
My dad wore hard contact lenses, but that's only because he came from an era where those were the thing.
Maybe not.
I want to say that Z equals R is a cone, yeah?
Yeah, Z equals R. That's the part that's confusing to me. And I'm wondering if if it's 0 to 4, I think I could do it easy. But so Jasper, you want to get us started thinking about this?
Yeah, so I first kind of wrote out all of the bounds. So we have z equals r to z equals 4, theta equals 0 to theta equals 2 pi, r equals 0 to r equals 4. So since theta goes from 0 to 2 pi, you know it's going to go all the way around the z-axis. And then r equals 0 to r equals 4, you know, like the max radius from the origin is going to be 4, and the minimum, it's going to start from the origin. And so then I drew the top line as z equals 4 to show that it couldn't go above that. And then for the z equals r, so I was kind of thinking this would be sort of like some sort of kind of paraboloid going up. Because when r equals 0, z would equal 0. So presumably when r equals 0, you have a point at the origin. And then when r equals 1, z would equal 1. So it kind of like shapes up like that. and then all the way out to r equals 4 when z would also equal 4. So that would kind of be like the top bound.
Interesting. What if it were 0 to 4, Alex Powell? What would it look like then in the z?
Then it would be a cylinder.
It would be a cylinder,
I'm
right?
confused how we know it's not a cylinder.
Well, because you have a lower bound of r in the z.
Right, but when r equals 0, when like r equals 0, z equals 0, when z
It's true.
equals 1, r equals 1, so it's just like a paraboloid thingy.
Yeah, that's what Jasper was suggesting.
Is it a cone or a paraboloid?
Is it a cone?
I think it's a cone.
Yeah.
Why do you think it's a cone, Julius?
Well, I thought it was a cone, and then I did it on Grapher, but why? Actually, I'm kind of curious. Why did I think this was a cone? For z to be equal to r.
It looks like an ice cream cone without ice cream in it. Which is depressing to think about, but.
Yeah.
Now wait, you had the intuition. So what do you think, Max? You think it's a cone?
Yeah, I also think it's a cone.
Why do you think it's a cone?
So I think it's a cone because we know z equals r, and so z is going to be increasing at the same rate r is increasing, and that to me sounds like a linear relationship, and so that's how I think we know it's not, say, a paraboloid or something else.
Okay, wait, Julius.
Yes.
You said you confirmed this with your grapher,
Yeah.
and what did you see?
Like a cone.
Oh, okay. And now, do you have listening to Max or thinking about it a little more, do you have a sense of why it's a cone?
I mean, no.
So as you go out from 0 to 4, the z is going up in a linear way with 0 to 4. I think, yeah, that's what I like your explanation of it.
Yeah.
Okay, let's look at a different one. These are tough to conceptualize. This is oh my God, that's impossible to even read. So sorry. Let me find the.
Oh, wait. Yes, I do get it. Never mind.
Oh, tell me why. Tell me why.
Oh, well, I was thinking of r as rho, which doesn't work. But if you're thinking of, so like the r value is always going to be perpendicular to the z value, so it's kind of like y equals x, but like across. You understand what I'm saying? Like it's like y equals x,
yeah.
it's like you're rotating around. So that makes
Okay.
sense.
Yes, very good. Okay, so let me give you the bounds on this one and see if you can draw this. The 0 to pi over 6, 0 to pi over 2, and 0 to 3 of rho squared sine, all that stuff.
Can you repeat that, please?
Yes, 0 to pi over 6, 0 to pi over 2, 0 to 3 of rho squared sine phi d rho d theta d phi.
I have a
Yeah.
So if there is no function, do we immediately know that this is just describing some portion of a sphere?
Yeah,
Okay.
it is. It's some, and we just have to figure out what the portion is. Since there's no function, it's going to give a volume of part of a sphere, but it could be a conical, top or something like that.
Wait, is it d rho d theta d phi?
D rho d theta d phi. Mm-hmm. And the rho has to pretty much be, the pi over.
Oh, wait. Yeah, no,
Yeah.
sorry, I was thinking about
Yeah.
that backwards. Okay. I was like, rho going from 0 to pi over 6. What?
Yeah, so let's see.
Okay.
It's a weird shape.
That makes a lot better.
It's like
Okay.
it's like part of a cone. Maybe.
Yeah, it sounds like it's maybe part of something. So, help me get started thinking about this. Alex Powell, I have no idea how to start.
Well, first row goes from 0 to 3. So, that's going to be the distance all the way around. So, it's going to be some kind of like curved shape.
Okay, is it going to curve or is it just going to be a line? That's a general question, not just.
I think it's gonna curve
Why is it going to curve?
Part of a cone.
because of the. I think it's because of the 0 to pi root 2.
Okay. Well, I guess I'm confused maybe by what you mean by curve. I'm thinking of rho is just a distance from the origin, so it's just going to take over every distance from the origin from 0 to 3 is how I was thinking. Okay. So what about the 0 to pi over 2? What does that tell you, Charles?
The 0 to pi over 2 tells me that its base is in the first octant. Because it goes from the x-axis, which is at theta equals 0, to the y-axis.
So that's the hard thing. And in the first octant, you're only dealing with the first octant. Okay? Because that's what the 0 to pi over 2 part tells us. And then, Isabel, what about the 0 to pi over 6?
So that tells us the angle in between z and rho. So that means that the line... Well, that's confusing to me. I know how to draw it. I mean, pi over 6 is going to be a third of the way in between the z-axis and the x-axis. But I don't really...
Yeah, what does that look like?
So
I'm thinking that this almost looks like a chunk out of a cone.
I think it does look like a chunk out of a cone.
Or like a pizza pie section on the top.
A three-dimensional piece of pie, yeah. I like that.
That gets skinnier.
Right. Phi Day is very special this year. Did you know that?
Pi Day? Oh, yes, it is.
Yeah?
Why?
Why do you know that it's special?
3.1415.
Yeah, so tomorrow Saturday is 3 point, and you're supposed to do something special at 9:26. I mean, it's not happening again ever. So, you should get excited. Okay, Julius, yes.
9
3,
2
That's actually really cool. What was I thinking? So wait, when
35 seconds at 9:26.
when rho equals 3, that's a sphere, yeah.
When rho equals 3, that's a sphere, yes.
Okay, so and then we have the first octant, so that's so now we've got a quarter of a
sphere. Okay.
Yeah.
And then the 0 to pi over 6 limits that quarter of the sphere.
So it's just cut in 3 now.
Yeah.
Okay.
So it's like a portion of a sphere.
So it's kind of like this, but only a quarter of it.
Right.
Oh,
so
it's round on top.
Yeah, it's rounded.
Oh, what?
It's rounded.
Oh, yeah.
Because it's got the sphere part.
Oh, yeah.
It's so it's like an ice cream cone cut in, I guess, quarters. Sort of. Okay. So it's easier to do this next thing, though.
Oh, that's a cool way to think about it.
Okay. So I think it's easier to go from this picture to the integral. So let's try this one. So we got a couple of pictures. So I'm going to use what kind of coordinates for this?
Cylindrical.
I'm actually not going to use spherical. I'm going to use cylindrical.
I was looking at my phone.
Okay. So I'm going to use cylindrical.
I'm sorry.
Okay. So that's okay. So help me out here.
It's get out of here.
Okay, I think this is easy in some ways, but it's also not so easy. We'll see. Actually, I think this is pretty straightforward. We'll see. Okay, Raheem, help me get started.
Okay. Well, what I was just doing was I'm going to the order dr, d theta, dz.
Okay, so we're going to do the order r, dr, d theta, dz. Cool.
And then just from the picture, you can see dz is 0 to 2.
Okay, cool. 0 to 2. You're done, Raheem. So 0 to 2 is this dz. Can someone tell me the d theta? How about you, Jack?
I guess would that just be 90 degrees or pi over 2?
Yeah, so we're going to go from where to where?
So from 0 to pi over 2.
Excellent. Okay, and now I need dr, and that's pretty... Julius, what about dr?
0 to 3.
Yeah, 0 to 3. Okay, so that's like a wedge of cheese. A wedge of cheese. Okay. Okay, now here. Now what do I do for this one? I want to do... What kind of coordinates?
Oh, I like that. Spherical.
Spherical. Isn't that pretty?
Like an igloo.
It's exactly like an igloo. I was thinking it was like a piece of candy.
This is the coolest shape I've ever seen in math.
I'm glad you like it.
Casey's like, this is blowing my mind.
Yeah, I'm like, I can't draw this. Also, it's really killing me how you have X on the left.
Oh my gosh, poor thing. It's killing you.
It has to be like a right-handed coordinate system.
No, just stop.
I know.
I've kind of gotten used to it.
It's because it's not going from... The theta isn't going from 0 to pi.
I know. It's
okay. I apologize. I'm sorry. I'm a bad person. It's
What's
true.
wrong?
It's just, why would you...
Why would you do that?
You couldn't see it otherwise.
Theta.
Okay. Oh, wow.
Oh, I was doing it cylindrically. God, cylinders, they just get stuck in your head.
Just get everywhere. Mess everything up.
Right.
What's the pattern on the cylinder? Or on the, like, igloo?
It's just like...
It's a very nice pattern.
Yeah, it's a grayscale of a color.
Oh, this was easy as well.
Okay, Alex, get us started.
Oh, is he?
Go ahead, Alex.
Oh, me, Alex. Sorry.
Yeah.
So for, I guess I'll start with the row coordinate or the row integral. It's just row goes from 1 to 2.
Okay, I agree. Row goes from 1 to 2. Actually, Alex, can you help me out and remind me what all the junk that needs to go before the d rho, d phi, d theta is?
Pi squared, or I mean pi, rho squared sine phi.
Yeah, rho squared sine phi, d rho, and we'll just do d rho, d phi, d theta to be easy. Okay, Eric, thank you, Alex. So rho goes from 1 to 2. Eric, what about phi?
Phi, I said, went from 0 to pi over 2.
Excellent. And Isabel, finish this for us.
So
Theta goes from
pi over 2 to 2 pi.
To 2 pi. Okay, great. And that's a cool thing, right? So you could, if you computed this, huh?
Can we build it?
You know, I wish I could. I mean, I can't.
Let's do that.
Actually, we have a 3D printer.
Yeah, senior project.
Oh, that's true.
You definitely
Mr.
could do
Spraggins,
one.
I need to tell you a math anecdote after class.
Okay, I can't wait to hear it. Yes, Charles.
Could you do theta the other way around, or would it give you a negative volume?
That is a good question. I do not know the answer to it.
Could you go from 0 to minus?
I think it should work
3
out
pi
okay.
over 2. Okay.
I think you should be. If you did it from 0 to negative 3 pi over 2, I think it should work out, but I don't know. Okay, so are we feeling better about some? I mean, it's easier to do this than it is to do the other, I think. Okay, let's look at these. I mean, these are. I just want to do something really quick with this. Let's just say what we're going to use. We have 3 choices now for triple integrals. Okay, we can use, cylindrical coordinates, rectangular coordinates, or spherical coordinates. And I just want to say, let's just choose which ones to use. Okay, so I'm going to just call on people round robin. Number 12, Jack, what would you use? Would you use rectangular, spherical, or cylindrical?
Rectangular.
Yeah, me too. Okay. I don't even know why I would use an integral here, except you have some density here. It's a variable density. Okay, number 13, Max, what would you use?
Cylindrical.
Yeah, cylindrical, because you don't have any curviness to your top. Okay, number 14, Samya.
I think I'd also use cylindrical.
Yeah, me too, because my top is flat, I would use cylindrical. Okay, number 15.
I have to go.
Bye-bye.
Okay, thank
We'll
you.
miss you. She's going to
Have a good
take a
spring
Latin
break,
exam.
everyone. Yeah.
Have a good spring break.
The national Latin exam.
The national Latin exam.
Good luck.
I've taken that.
I know.
I
Fun,
feel
fun,
like
fun.
you would seriously support that, Mr. Spraggins.
The national Latin exam?
Yeah.
You know it. Okay, number 15, Alex Powell.
Solway.
Number 15, I would use spherical.
Yeah, and that one's actually not
Okay.
hard to set up. I mean, it's because of the fact it's like have you seen those things where you put them on a table and
Oh yes, I love those.
So that's like what that's like.
The physics of it.
Oh yeah.
That's kind of what we just did.
Okay, now notice number 16. It says it's a piece of a sphere. The angle at the center is pi over 3. Julius, what would you use for that one?
Spherical.
Yeah, I use spherical too.
When it says the angle at the center, does it mean the angle from like the center axis to the wall, or the
I
angle
think
from
it's
wall
like
to
this,
wall?
to this way.
Okay.
Okay. Number 17, Raheem, what would you use?
Just rectangular.
Yeah. And number 18, oh, this one's interesting because it's a cylinder minus a cone. So what would you use there, Eric?
I would use cylindrical.
Yeah. Okay. Now I want to do number 16. So let's see if we can write the integral for 16. So we're using spherical coordinates. What are the limits on the row, Max?
For 16?
Yeah.
Row would go from 0 to 3.
Okay, row would go from 0 to 3. Everyone okay with that?
Yeah.
Okay. What are the limits on the phi, Jasper?
The phi, I think it goes from 0 to like pi over 2. No, it's 0 to pi over 4.
Well, it tells you that the angle at the center is...
Oh, it's pi over 3, so, well, I guess pi over 3 then.
Yeah, I mean, I'm assuming, I am interpreting that to mean the angle from that may be a bad interpretation, but that's how I'm interpreting it. But then what about my d theta, Eric? What would my d theta be?
0 to 2 pi.
Yeah, right. So these are actually not that hard to set up in some ways if you've got a nice picture. Okay, let's see if we can do this really quickly. So let's write a triple integral. And
Mr. Spraggins?
Yeah, Alex.
Sorry, what did we say the d phi was for the last one?
Well, I'm assuming that the angle here, Alex, that this, like from a line drawn here to here is what they're talking about the angle at the center is. Okay. That may not be accurate. They may actually be talking about this angle at the pointy part, but I'm interpreting it to mean, so my bad if I'm interpreting it wrong. Okay. Okay, so let's see. Write a triple integral representing the volume of the cone below. Wow. Okay. How can I do this? Isabel, help me out.
Okay, so first I would put it on a coordinate axis and just define, I would just say that x. I mean, when you do the triple integral, you'll do it in cylindrical coordinates, but for now I would just say, x is going to go from 0 to 5 divided by root 2, and then
okay, so
calculate.
Wait, where's your axis? Is it on the base of the thing or on the circular part?
Yes.
Okay.
And so then I would just calculate. I would make a right triangle to see how much z changes.
Okay, let's do this.
Okay.
So she's saying set up an axis here, I think.
Yeah.
Whoa. That's a terrible drawing, but, you get the idea.
I get that, Izzy.
Yeah, boy.
Oh, crap. And then you have to do the right triangle.
Honestly, I don't even know how much math you have to... Well, I think the only thing you need to calculate is the z value, and you should be golden.
Yeah, I don't know that it's so hard to do. I mean, it's kind of a funny problem because, I hope you all know how to find the volume of the cone without calculus, but it's one of those things that I think it's a good heuristic for you to be like, can I do this with
Get on those right triangles, Paul.
Right triangles, I know.
It's like.
Puts me 50. Plus
Are you ever like
right.
super impressed with your drawing?
With my own drawing?
Yeah,
Never.
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 Oh,
Because
that's 5 over.
I'm not a very good drawer.
I thought it was 5 times root 2. Alright,
Sometimes
so it's
I'm
gonna be 25
Quite impressed.
divided by 2, so 12.
Yeah, it's got a special property there. That's you're super impressed with
Oh,
that
true.
drawing.
It's
Matt?
5 root 2. You don't even have to.
Oh,
do
come
math.
on.
Okay.
You don't even need.
Look, I got the little lines going around.
No,
I'm
That was my
not
favorite
good
part.
at any math that I even touched the calculator.
Okay, Isabel, you got to start it. You got us going down this path.
Terrible phone.
Yeah, Charles.
Oh,
Okay,
Oh
so
god.
a bit. You shouldn't even need to do math because you should immediately look and say, "Oh, that's just an x root 2, right?"
Yeah.
And so you should get that z equals 5 root 2. So then, can I?
I think it's. I try again.
Over root 2.
Yeah, 5 over root 2. Yeah.
And then, can I say the integral?
Yeah, say the integral.
So r goes from 5 over root 2 to 0. Theta goes from 0 to 2 pi, and z goes from 0.
So wait, it's from 5 over. You mean 0 to 5 over root 2?
No, because
No.
my circle is on the bottom.
Oh, I see. You're going like your axis is way over here.
No, my axis is going. My axis goes.
Where's the origin of
through
your
the
axis?
Circle. The center of the base is
Okay.
is the origin.
It's here, right?
Yes.
So explain to me why your r is going from 5 root 2 to 0.
Because as you go up z, r is shrinking.
Oh, I see. So you're going, huh. Okay. Well, anyway, go ahead and say your integral.
So. Okay, so r goes from 5 over root 2 to 0, theta goes from 0 to 2 pi, and z goes from 0 to 5 root 2. 5 over root 2, sorry.
I don't know that I like the r. Maybe you all
Isn't
can
that just like a
convince me.
cone?
What, Jasper? Go ahead.
I feel like that's like a cone, isn't it? I mean, I feel like that's just like a cylinder if it's just 0 to 5 over root 2, isn't it? I mean, for r.
Yeah, the r has got to be. There's got to be a variable somewhere.
Oh, so z and r are equal,
Well.
right?
I don't know. You tell me.
Negative. Well, they're inverted. So maybe you should say z goes from 0 to negative r. Or like r, it goes from. Sorry. Z goes from. Something to do with r.
Okay. I'm glad we got that clarified.
No.
Jasper, you want to try?
Yeah, so, well, so R and Z, I'm trying to think of like a line that contains both R and Z. So, because Z equals R doesn't work because if we're using the bottom as our origin, then that's equals 0, Z equals 0 and R equals 5 over root 2.
0 to 5.
So, yeah, maybe we can do R times 5 over 2 equals Z. No, doesn't work.
I don't know. Okay, wait.
Yeah, that's what he just did it right.
You think so? You think that works?
5 over root 2 minus r equals 5 over root 2 minus z, or z equals 5 over
5 over root 2 minus z, that's what I think. Is that what you said, Jasper?
Yeah.
Okay.
Yeah, the 5 over 2 minus Z.
Okay, Charles, what do you think?
Yeah, I was going to say z is 5 over root 2 minus r.
Okay, yeah. So I think that will. I misheard you, Jasper. I apologize. You know, did anyone think about turning it upside down and putting the origin like at the right angle? I'm just curious. That would also work. You know, I mean, you could just flip the thing. Yeah, you have a problem with that idea?
I know, I thought about it because it's like the one we did earlier.
Yeah, it would be exactly the same. So, I mean, any kind of simplifying thing like that might help. Okay. I want to make sure that I don't want to. This is a really classic problem that you may encounter in your lives, so I just wanted you to know that this is have you heard this problem? So could you read it for us, Raheem?
Yeah. Two cylinders, the x and y axes form the axes of two right circular cylinders with radius 1. Find the volume of the region that is common to the two cylinders.
Okay, so do you see the region that I'm talking about there?
Mm-hmm.
Okay, and then 3 cylinders. Go ahead, Raheem.
The coordinate axes form the axes of 3 right circular cylinders with radius 1. Find the volume of the region that is common to the 3 cylinders.
Do you see what a pretty shape it makes? In the lower right-hand corner. This is like one of the most famous problems that really people were fascinated with when, from the 17th century on. You might encounter this problem in your life, and it might be fun for you to think about how you could use triple integrals to find the volume. We're not going to spend time doing that now, but this is a problem that you could do with triple integrals, and it's a very, very famous problem. Isn't that a pretty shape? Do you like it? I can tell you're intrigued. Max, are you intrigued?
Yeah, I'm wondering how many you need.
Yeah, how many do you need? Why do you think you need more than one?
Just because there are a lot of different regions where your bounds would be different.
Well, I think maybe, how many, think about the one at top. Isn't it a slightly simpler problem than the one at bottom? Or no?
Yeah, yes, I believe that is a similar problem.
So, I don't know. I mean, I encourage you to think about this. Okay, we need to talk about improper integrals because we haven't. Remind me what an improper integral is. Yeah. Yes, Isabel. Improper. I know, exactly. You just have to giggle when you see the...
Yeah, no. So basically, an improper integral means that its limits or bounds go to things that are no good.
They're no good. They're either...
Infinity.
So they either go to infinity. Okay, that's bad. That's not good. There's another problem, though. It could be...
That...
Yeah, I mean, you're right. No good. What is the other problem?
Going to somewhere undefined.
Yeah, we're not defined in the domain. Okay? So, how do you think you would deal with something like this? Eric, do you have any ideas?
Remember all of our limit. I'm pretty sure in single variable calculus you would rewrite, when you have an improper integral, you rewrite it as a limit.
Yeah.
And then you sort of evaluate the limit and you see if it, how fast things are growing, sort of.
Yeah.
Does that mean we have to remember all of our convergence tests?
I don't really.
No, I don't think so. I don't think we have to. I think we could do this easier. Yeah, Eric, you're going to say? Sorry.
That was it, basically.
Yeah. What about, how would you attack this problem if I, said you have to or else? Julius, what might you do to think about this problem?
Oh.
Normally the first thing I would do is try to draw the region, but I can't do that.
Yeah, okay, so that's no good. So there's a clue in the way the thing is written.
There's a clue, you said?
Yeah.
We have our x squared, the square root of x squared plus y squared plus z squared.
Right. So that simplifies nicely in what system?
That's row, and spherical.
In spherical coordinates. Yeah.
Yes.
Yeah. So what would the square root of x squared plus y squared plus z squared be, Julius?
Row.
Okay. And then what would so how could you rewrite that integral? Max, want to try? Without the improper part. Just makes me giggle every time I see it.
I don't get it.
No.
I was too self-conscious to do that in BC Calculus this year, I have to admit.
Why? Really?
I was just too self-conscious.
You don't like them as much as you like that.
I just couldn't do it. I've done it every time I teach improper integrals, but I just could not do it.
Something about the class.
It's a gigantic class. Do
you think Anna would judge you?
Yes, she would.
Who else?
She would what?
She would have judged me.
Who else are you embarrassing?
Max Steiner would have judged me. Okay, wait. Max, you were trying something here.
Yeah. So I think that integrand would turn what's right there would turn into rho times e to the negative rho squared.
Yeah. So rho times e to the negative rho squared. Ooh, that sounds scary.
Which sounds pretty.
But you could do that by
substitution.
Substitution. Okay, but there's a problem.
But
what
we
is
need to
dx dy
add-
dz?
Yeah, that would be rho squared sine phi, and then either.
Yeah, and then you have to do. So now you've got a problem. So you've got rho cubed. Oh my gosh.
Yeah.
How would you do
so-
rho cubed?
Well, then I need to go back. I think I would think about the definitions of like rho. If rho is x squared plus y squared plus z squared, and x, y, and z are all going from negative infinity to infinity, then I want to say rho would go from negative infinity to infinity, but I'm not sure if a negative rho value would make sense.
Yeah, so that's one of the things about this is how can you set the integrals? Yeah, go ahead.
I think you'd have to be careful with negative rho values because if you have like negative rho values, but your theta goes all the way around, you'll count everything twice.
Yeah, but you might want to do that.
Why do you think you want to do that?
Well, because if you have, because if x, y, and z are all squared in here, say it was from 0 to infinity, right? That would kind of be like rho goes from 0 to infinity. Maybe. But since you're going from negative infinity to infinity, I think that might be counting it twice.
That's interesting. Well, but what about the fact that you're squaring all the terms? Does that confirm your idea, or?
I feel like that kind of confirms my idea.
Yeah, go ahead.
I think that like negative infinity, because rho is just a distance from the origin to the point x, y, z. Even if x, y, and z are all negative infinity, rho will still be positive because it's a distance, or could still be positive.
Yeah.
You could still represent that point positive. It would just depend on your theta.
Yeah.
So I think
That's one of the things. I mean, what do you think? But then, what do you think you do with the d phi and the d theta? I mean, Isabel, do you have any notion? Wait.
Sorry.
Isabel, what do you think you have to deal with the d phi and the d theta?
In an improper integral.
Yeah, I know. How do you?
I mean,
this?
the thing is with phi and theta, they really can't be improper. Okay, that might not make sense, but I mean, like.
No, I hear what you're saying, and that's what I like what you're saying.
Okay, so like phi and theta, like they just start over if you get too big a value. So I feel like unless you have like the undefined thing, so I feel like if we're in.
So it doesn't make sense to think about theta going from negative infinity to infinity. It only makes sense to think going from 0 to 2 pi.
Right, because if you're finding a volume, like I get it if you're trying to find surface area, then I guess technically you could just like keep recounting.
Yeah.
But with volume, it's just it's already a volume. So then it wouldn't make sense for phi and theta to ever be written with.
And in fact, I think there's some limits on what phi, for example, can be. I know there's some limits on that. Julius, do you have any thoughts about this problem?
I'm thinking.
Yeah, I like thinking. I'm a fan.
Well, I have a question. Oh, never mind. Well, it was about the equals 2 pi, but is that just like if you were to actually have done it, that's what it equals?
Yeah, that is actually what that equals, which is kind of miraculous, isn't it? I mean, come on, that's incredible. Be amazed! That's 2 pi.
Wow.
Jasper, any thoughts?
Well, I mean, like, can you just say since this is going from negative infinity to positive infinity in x, y, and z, can you just say, like, for phi and for theta that phi goes from 0 to pi and theta goes from 0 to 2 pi, just because you know that, I mean, unless there's an undefined place, that's going to be the case.
And what do you think the rho would go from?
Well, I don't know.
Yeah, okay. Julius, you've been thinking.
Oh, well, no. Also, you took issue with the idea of substitution earlier. Why?
Well, because you have an extra factor of rho squared.
Oh, that's...
Because the dx, dy, dz isn't just dx, dy, dz, it's rho squared.
Yeah, but... I get
Sine
it.
phi d rho d phi d theta.
Yeah, I was thinking of a way that you cannot combine those things. So.
Yeah. Okay, so, Jasper, go ahead.
Well, I couldn't rho go from 0 to infinity. I mean, I know you still can't have the infinity because it has to be, but can't we? I mean, isn't that the only thing it can be? It's from 0 to infinity, because especially when you rewrite it, you have rho e to the negative square root of rho, so you know that it can't be, rho can never be negative in that sense.
Yeah, I mean, I don't know. Jack, what do you think?
I'm rather perplexed.
It is perplexing, but kind of cool. Yeah, Isabel, you've had a thought?
Well, the thing is, when we have improper integrals, the reason I feel like we're allowed to have functions that go on to infinity is because, like, the area stops changing after a certain point, or like the volume, like if something.
You mean
like
why they might converge? Is that what you mean?
Right, like
yeah.
If they converge, like are we allowed to have improper integrals that diverge?
Well, this one we know converges because I have said, this one equals 2 pi.
But I mean, in general,
sure.
Like, are we allowed to have them?
Absolutely.
So then, if we can have like Cartesian improper integrals that diverge like off into infinity, then I would say that rho can as well.
Okay. Alex Powell. What are you thinking?
I'm still a little just trying to catch up and understand.
Okay, so let's see if we can help Alex Powell. So first of all, square root of x squared plus y squared plus z squared. How do you write that in spherical coordinates, Alex?
So you have rho.
Okay, and then you have e to the negative that, so that's negative
rho squared.
Okay, and then you have to write dx dy dz. How do you write that?
Rho squared sine phi, and then d rho d theta d phi.
Yeah, or d. Okay, and so one of the questions that people have been asking and struggling with a little is, so phi and theta are, can you go from negative infinity to infinity? And I think that some people believe you cannot. And Isabel argued that you couldn't. Because why, Isabel?
Because they repeat values.
Yeah, so you only have a 0 to 2 pi is only the kind of the range of theta, and for same way with phi has a limited range. It goes from 0 to, I believe, pi. Okay, so Max, you want to have a word?
Yeah. So after thinking about this for a while, I went back to think what if we're thinking about this in Cartesian coordinates, what kind of volume or region, or I guess disk, if we're talking about volume, are we integrating over? And if it's dx, dy, dz, and all of those are going from negative infinity to infinity, spatially, what we're doing is just accounting for every single point in space.
Yes, that is true.
And so I think as long as we cover the same theoretical space in spherical coordinates, then it should be equivalent.
I like that idea. So what would that give you as your limits on your integrand?
And so I thought that phi, I agree with Isabel saying that phi should only go from 0 to pi. Theta should only go from 0 to 2 pi, because that is the maximum value that I can have. And then I agree that rho should also go from 0 to infinity.
Yeah, so let's see. I like that a lot. So, Alex, how does that feel to you?
Makes more sense, but I don't understand. I still don't understand the problem if you did go from negative infinity to infinity. Even if you did repeat values, it's still just going in a circle.
Right, but so are you asking why you can't on the integrand, on which part, d rho, d phi, or d theta?
D theta and d phi.
Okay, so if you think about what this integrand, the space that it's integrating over, it is, so think of a three-dimensional coordinate system, and it's everything, it's like the entire universe, okay, in that three-dimensional coordinate system.
No big deal.
That is the area of integration. Does that make sense?
Right.
I mean, you're thinking of every possible x, every possible y, and every possible z.
Oh.
So just converting it to spherical, which makes sense because of computationally it's going to be easier to do spherical. I want to describe that same space in spherical coordinates. So that same space would be, everything around, 0 to 2 pi, everything this way, because that's where your phi is defined from 0 to pi, but then you want to include all the space, all the other stuff out there, so that's the 0 to infinity for the rho, I think. Yeah, go ahead.
Well, to me, like when you're describing, it's infinite, like it's accounting all of space, but only like adding up volume that exists within the function. Like it's because there's a function that exists, so it's like a room with one object in it, and even though we can search the whole room for volume, so I feel like the bounds like in cylindrical or spherical could like say the same thing, that they're infinite, as long as like you have a defined function.
I think I understand. I don't think I understand what you're saying, but I may be just being dense.
I don't know really what I'm saying, but I get it.
I think if you're saying like if you're kind of going through all of space and adding up every value of this function,
right.
So as long as because it's just the function that you're adding up, it doesn't matter
what the bounds are because it's a closed function.
But I think that if you had bounds that were just infinite, like for theta, if theta was just negative infinity to infinity, you'd keep like spinning around on a sonar screen. You just scan it once and like add it, and then you scan it again, then you scan it again, and just keep adding it up.
Right. And I mean, basically, I think the one easy way to say this that may make sense to people, I mean, there are limits on what theta can be, really.
Right.
And there are limits on what rho can be. I mean, we want rho to be positive because it's a distance. And I also want phi, there are limits on what it can be. Did you have one last thought about this?
Yeah, no, I was just thinking about what Izzy was saying. And I think she kind of has the idea, because she was saying like you're searching all of space for an object, and I don't think that's technically right, because it's not like there's only one part of the space that we're searching that will actually give us values. I think it's almost like if you think of the function as like a density function, which it might be, you could probably say something like closer to the origin, it's extremely dense, but quickly. It's like a infinite series that converges. Like it has to quickly sort of get to increasingly smaller and smaller values.
Right. Now, one of the questions that we haven't really talked about, which is an interesting one, is how you actually integrate it. I mean, because if you had rho, and I actually don't know, so I'll be honest with you. If you would use integration by parts, if you would try to use some kind of it's not easy. It's not obvious to me how you would actually do the integration at this point in time, but it's a pretty cool problem to think about. So obviously, the whole point of this is that you can have improper integrals in multiple dimensions, and therefore, here we are in multiple dimensions. Now, I want to make sure that you know these three things. Our next class is Thursday, April 2nd.
Oh.
Thursday, April 2nd.
Oh.
Which is, let's see, today is the 12th.
That's not even that far away.
It's 3 weeks away.
Really far away. It's very far.
That's 3 weeks from today, Isabel.
Yeah, Isabel.
And if Akshay were here, he would be crying. Because Akshay hates it when we don't have class. So have a wonderful spring break. You don't have anything to do for spring break, over spring break. I adjusted the schedule because I think we're not going to talk about. I mean, the Jacobian is a very cool thing, and if you watch the stuff in the Jacobian, good for you. But we're not going to spend class time on it. So I love the Jacobian, but anyway, so I adjusted the schedule, and that should be all set for you. Have a good spring break, everybody. Good to see you all. Lovely day. Bye bye.
Thank you.
Hey, Isabel, did you?
It's kind of hot.
Have you end? Do I hit end or is it already done? Already ended. Oh, really? Because the timer's still going.
Oh, yeah. Then you
Hit end.